Today I want to show you how to build a simple TypeAhead or autocomplete feature using nothing but Firestore. This solution is ideal when you only have one or two properties that you want to search by on a document, and you want to avoid using a third-party service such as Algolia or Elasticsearch. It's much easier to implement and maintain this feature directly in Firestore, but it's not going to have quite as many features as you would find in a full-text search engine like Algolia. It works by breaking down a string into a series of substrings and saves them as an object on each individual document. Then we can query Firestore based on these substrings. In this demo, we have a movies collection, and when we add a new movies document, it creates a searchable index. I'm going to show you how to set this up in a cloud function, but you could also do it client-side. But what it's doing is creating an object where each key in that object is a string that gets progressively larger. That allows you to make queries where a certain document has a title that starts with W or WA or WAL and so on. Again, the cool thing about that is we don't need to use or pay for any third-party dependencies, but the drawback is that the user has to enter their search term correctly and it won't be robust to spelling errors and things like that. So this works best when your needs are simple. If you have really complex multi-property searching that you need to do, I would still recommend using something like Algolia. Now that we know what our data structure looks like, I'm going to start by building a TypeAhead component. The component will provide a form input and then display the 5 most relevant results that we get back from Firestore. Let's go ahead and import Firestore as well as observable, subject, switch map, and filter from RxJS. From there, I'll set up a results observable, which is the Angular Firestore collection observable that we get back from the query. That'll be an array of movie documents. Then I'll set up a subject that we can use to observe the user's form input. So that's the string offset that they want to search by. After that, we can inject Angular Firestore in the constructor. Then we'll listen to the key up event on the form input. Then every time we get a new value from that event, we're going to update the offset subject by calling next on it. And we're also going to standardize everything as lowercase, so we'll make sure that that form input is formatted in lowercase. The next thing we want to do is observe that offset value, and we're going to filter out any blank results because that will throw a Firestore error. And then we'll switch map to a new observable of the actual results that we get back from Firestore. We do that by making a reference to our movies collection. Then we can format the query to order by the actual offset that the user is searching by. So we can do that by calling a property on the searchable index that is on that document. If the user types in W, it's going to return all the movie documents that have a title that starts with W. And we'll also limit that to 5 documents just to make it an efficient query. And then lastly, call value changes on it to return the observable. And finally, we will initialize the results observable when the component is initialized. What we have here is a dynamic query that depends on the form input, so the query to Firestore won't actually be made until that user starts typing into the form. If we jump into the HTML, we can just set that up by setting up an input and then binding it to the key up event. And our results are just an observable array, so we can loop over them using ng4 with the async pipe. Currently, we don't really have much of a front-end style applied to our autocomplete, but if you use something like ngBootstrap, you can use the same logic to populate the data for that autocomplete component. So at this point, we have a working autocomplete, but we need a way to dynamically add the index whenever a new document is created. For that, I think the best approach is to use Cloud Functions, but you could also do it client-side if you want to. I have Cloud Functions initialized with TypeScript, and I'm also bringing in the admin database. Then I'm going to create a function called updateIndex, and that's going to run every time a new movies document is created. Then right below that, I'm just going to create a plain JavaScript function called createIndex that takes a title as an argument. We'll define that later, but for right now, we'll go ahead and get the movie ID as well as the movie data when this function is invoked. Then we'll take its title and break it down into an object with a series of substrings based on that input. And that'll be the actual index that we query against. So we'll go ahead and take that and combine it with the original movie document. We can easily do that with the spread syntax in TypeScript. And then the last step is just to make a reference to this original movie document and update it with the new data. So we'll go ahead and call set with merge true, but you could also just use a plain update here as well. So that's all we need there, a pretty simple update function that runs when a new movie document is created. Now we'll go ahead and define the helper function that actually formats the data structure. We'll go ahead and take the input string and format that to lowercase, and then split it up into an array of its characters. Then I'll define an empty object for our searchable index. Then I'm going to loop over all the characters in that array and keep track of the previous key that we used over each iteration. That just allows us to append the newest character to the previous string of characters that we used on the last key. Then for each iteration, we'll set that key on the searchable index object and set its value to true. Once we reach the end of the loop, we'll go ahead and just return that index. Again, if you don't want to use a cloud function, you could easily take this helper function, put it in your front-end code before making the update to Firestore. Let's go ahead and deploy our function and test it out. If you go into the Firestore console and create a new document under the movies collection, you should see the searchable index created automatically under that document. That'll give you a basic case-insensitive search feature, and you don't have to rely on any third-party dependencies. Jumping back to Angular, you should see updated results in the autocomplete anytime you add new documents to the database. I'll go ahead and wrap up the video there. If you have any questions or want to talk about the pros and cons of this approach, just drop me a line on Slack. Thanks again for being a pro member, and I'll see you soon.